Here we are at our example 2 from our 3.57 notes. We're asked to write an exponential function whose graph passes through the following pair of points. Now, keep in mind, to write an exponential function, we are talking about this form where we have y is equal to sum a times b raised to the x power. And a lot of times we throw those in parentheses for that b, that base. Now, looking at our two different points, we have some xy associated with it. We'll label him the red one. And then also some xy, we'll label this guy the green one. Now with these 2 points, what we can go ahead and do is kind of treat them separately. So again, instead of y, if these 2 points work for this exponential function, then what we can go ahead and do is plug them in for x and y. So for the red one, we'll go ahead and substitute these values in. So instead of y, we have 2 equals, right now we currently don't know what a and b are, so we're still going to leave those as a and b. But luckily we do know our x value. It is, in this case, for this particular point, the red point, it is 2. And not much can really be done beyond that. So we currently just have, again, 2 equals sum a times b squared. And again, you can't really solve, just say that like a is 5 or b is -7. And as a result, we're then forced to go to our green one. Now we're pretty much going to follow the same exact setup. We know an x, we know a y, we're just going to dump it into our exponential function. And when we do that, we end up with 1 equals, again, still don't know what a and b are, so that's still just a times b. But luckily we do know the exponent for b. It is, in this case, for this particular point, 3. Now there's a variety of ways that we can continue solving for this. But the moral of the story right now is that we do have a system of 2 equations that work for this particular exponential function. And we know that they work because this point and this point both reside on that exponential function. In other words, if you were to graph it, this point would be on it and this point would also be on it. Now, how we continue from here is, again, there's a lot of different approaches that you can take. Typically, if you have an a value like this or an a value like this, it might help you just to solve for that single variable, as opposed to, for example, like the b cubed or a b squared, because then you're talking about nth roots and you kind of want to try to avoid those as much as possible. It can be done algebraically, but you want to, again, avoid that as much as you possibly can. So just looking at our red one, let's go ahead and solve for the a value. Now to solve for the a value, in other words, if we want a all by himself, what we would have to do is divide this b squared on both sides. Because right now a is being multiplied by our b squared. If you want a all by himself, you'd have to, again, divide by that b squared on both sides. So on the right side, we see that they just kind of cancel out. The b squareds, we were hoping for that, leaving us then with just our a on the right side equals our 2 over b squared on the left side. Now at this point, what we're hoping to do is, now that we have a variable solved for, we know that a is equal to 2 over b squared. We're going to substitute it in to the other equation for a. Now the whole reason why we actually want to do that is it's going to show up in the next line right here, where we have 1 is equal to, it's no longer a right here now, it's 2 divided by our b squared. And this is still being multiplied by our b cubed. Now notice, from this line right here, this green one, we had an a and a b, 2 unknowns which you really couldn't do a whole lot with, even likewise with the red one. However, by doing this substitution move, like we've done, the only variable that's involved now are just b's. And from that, then you can solve for a single variable. And that's really our end game. That's why there's so much power behind this substitution method. So just kind of cleaning up the right side, we end up with 2 times b cubed over b squared on the bottom. And using some just properties with exponents, we know that our values will end up canceling out. If there's 2 on the bottom and 3 on top, we're going to be left then with just 1 left on top. And so then it looks like we have still 1 equals our 2b. And then lastly, just to solve for b, we would just divide both sides by 2. So b now is all by himself equals 1/2. Now to solve for a, we pretty much just substitute that value in. We're going to substitute in our 1/2. Now you can do it into the original green one, you can do it in the original red one. Believe it or not, you could actually even do it into this red one, because really this is a simplified version of our red one, this 2 divided by b squared. Just to not to have to really worry about fractions over fractions, let's go ahead and use the original red one. So looking at the original red one, we have 2 equals our a value times, instead of b, we see that we now have a 1/2. And that half is eventually being squared. Again, just using the original red one. So on the left side, we still have our 2 equals a. Looking at this part, we are having powers raised to powers. So that's our power to a power property from exponents. So we know that we multiply those two, giving us 1 raised to the 1 times 2 is 2. Whereas at the bottom we have that base 2. Again, power to a power, we're multiplying those exponents, those powers, so we end up with 1 times 2 on the bottom is 2. So we still have 2 over on the left side is equal to a times 1 now being squared gives us 1. On the bottom, 2 squared gives us 4. And then lastly, to solve for a, we just have to multiply both sides by 4. 4 times 2 will give us 8 equals, on the right side, a fourth of 4. Those will just cancel out, leaving us just our variable a. So now that we have our a and we have our b, we can go ahead and construct our equation for this exponential function. So pretty much just substituting values in. Right now we're going to leave y alone, equals our a value we know is 8. We now know our b value, it's a 1/2. All of that raised to the x power. The reason why we use or leave x and y alone is because if you think about it on a graph, let's just say that this is more or less the shape of our graph that we've seen in the past. This is going to work for many, many, many different x, y coordinate points. It's going to work there, it's going to work there, here, wherever. It's going to work for many, many different x, y coordinate values. Throw some arrows around. Again, many different x, y. That's why, again, we leave these as x and y's. So this would be our final answer. Again, that is example 2 from our 3.5 set of notes.